Program number 4, Accessible Sidewalks, Design Issues for Pedestrians Who Are Blind. This runs 11 minutes and 19 seconds. With Lorinda Steele-Lacey of the Access Board and Ron Miller of the U.S. Veterans Administration.
Every day, as pedestrians and drivers take to the sidewalks and streets, we rely on the work of traffic engineers to make sure that our paths don't cross at the same time. Curbs, crosswalks, signs, and signals separate pedestrians and drivers and regulate the use at street crossings we share. Increasingly, pedestrian safety depends on information provided at intersections by traffic control devices. Most of this information is visual, but for blind pedestrians, audible and tactile cues like traffic and pedestrian sounds, and the slopes and edges and elements of the environment are most useful. When that information is available, it makes independent travel easy. Hi, I'm Lorinda Steele-Lacey from the Access Board, the federal agency that develops accessibility guidelines under the Americans with Disabilities Act and other laws. My colleague, Ron Miller, and I spent a very cold day on the sidewalks of Washington recently to demonstrate how we gather travel information and to point out some places where more information would be useful. Whether you use a cane or a service dog, sidewalks and street crossings can be designed to provide useful cues and landmarks and the consistency that makes them reliable for independent travel. I use a long cane to navigate. In familiar territory, like this sidewalk in front of my office, I can travel fairly quickly between known landmarks using the sound of parallel traffic for orientation. When these sidewalks were rebuilt a few years ago, they were designed with a broad central travel zone. The new benches, landscaping, signs, and bus shelters were all grouped in a strip along the curb, out of the way, easily detectable, and best of all, standardized. If all sidewalks were as straightforward as this one, we wouldn't be making this video. When I'm traveling an unfamiliar route, I may use my cane to find and follow a shoreline. In this block, the raised curb is a helpful guide, since open areas don't reflect sound like building facades do. The overhanging bumper identifies this as a parking lot, always a tough routing to anticipate. Here's a real obstacle. This sign projects into a pedestrian route at a height that's more than 27 inches above the walking surface. This means that the arc of my cane doesn't pick it up in time, and my stride carries me right into it. This could be a useful landmark for a change in direction if it extended down to a detectable height. In the open space of this park, there's no traffic sound to use for orientation, so I followed the tactile shoreline of the grass edge. While this drinking fountain needs to be 27 inches high to provide knee room for someone in a wheelchair, it doesn't need to project over the sidewalk like this. My cane picks it up, another landmark for me, but it would be better if it were located clear of the travel route so I don't come through when someone's trying to get a drink. And there's no reason this bench needs to be in the middle of the sidewalk right close to a busy intersection. It's well within detectable range, but why put it here at all? And keeping the sidewalk clear may not be enough. Signs, awnings, and especially tree branches like these that protrude from overhead can be an obstacle if they're less than 80 inches above the ground. People who are blind determine when to cross streets by analyzing the sounds of traffic. At fixed timed intersections where the street grid is regular and there are opposing traffic flows to provide information, blind pedestrians can time their entry into the street to nearly coincide with the walk light. However, non-perpendicular geometric designs, unbalanced traffic flows, and signals that require pedestrian activation make intersection diagnosis more complex for blind travelers. While it's not hard to find the sidewalk edge here, it is difficult to analyze traffic flow, and the two nearly parallel streams of traffic make it difficult to fix the crossing interval and direction. An audible equivalent to the pedestrian walk signals installed here would give me useful information on both issues, when to start and where to aim. It's important to someone who uses a wheelchair to have a curb ramp that is perpendicular to the curb, so that both sides of the curb ramp are the same length. So you'll find that many curb ramps are located at an angle to the crosswalk. I try not to use the angle of the curb ramp, or even a curb for that matter, to determine crossing direction. What I rely on here are traffic sounds, pedestrian sounds, and the differences in the sound and feel of my cane as it touches different walkway materials. Here I use the granite border of the crosswalk as well as the sounds of parallel moving traffic to help me refine my direction. There are some places where a unique tactile cue would really help, and here's a good example. I know by the traffic sounds that I'm near the intersection here, but there's no curb face to tell me where the sidewalk stops and the street begins. And the slope is so gradual that other cues I might use, like where the counterslope of the gutter begins, aren't available either. Depressed intersections like these may be fine for delivery men, like the one trying to get his hand truck by me here, but they're not necessary for wheelchair access. The tactile border treatment could provide a confirming cue that I'm looking for here. A great deal has changed in geometric design and traffic operations since Ron and I attended orientation and mobility training. Traffic engineers are using new technologies to move more cars faster through our congested cities. But this often means that the familiar intersection design and traffic controls that I base my travel analysis on are disappearing. Now, complex turning operations with parallel and perpendicular traffic moving at the same time mask the sound cues I rely on to know when to cross. And roadway designs have changed too, with separated turning lanes that may move traffic more efficiently, but make one crossing into two for pedestrians. No problem. Change is good. In fact, I have great hopes for the kinds of changes that I hear are coming from the new intelligent transportation systems. But I want to make sure that my interests are included when decisions are being made about the next generation of traffic management systems. Here's a good example why. This complex intersection has a right-hand slip lane for northbound traffic and access roads on both sides. And there's a major metro station here served by a number of bus routes. Lots of congestion, lots of choices to make, and lots of information available to the sighted pedestrians, including several sets of walk, don't walk signals. Question: why not pair visible and audible signs and signals so that all pedestrians benefit? This intersection presents a particular problem for Ron's dog, Hunter, who's trained to head for the opposite sidewalk on command. Once given the direction to cross, he doesn't stop at the median. An audible signal could have given Ron the information about the crossing that he could have used to direct Hunter more accurately. Well, Ron and Hunter are ready to head home, this time by bus. There's a sign and a schedule posted at the bus shelter, but Ron must rely on the bus driver to call out the route. No problem when there's only one bus here at a time, but later on, in rush hour, it won't be so easy for Ron to pick out his bus from all of those waiting at this stop. Audible and tactile cues are particularly important in unfamiliar territory, where you haven't yet identified the landmarks of a regular routing. But to tell you the truth, even an everyday commute can't be counted on to be routine. At this intersection, the traffic lights are flashing red. There's no traffic pattern I can pick up, so I'll know when it's safe to begin crossing. The law says that drivers are supposed to yield to a pedestrian using a white cane, but you can see how few of them do. That's why having street and traffic information available is so important to independent travelers. You can't always count on there being a helpful pedestrian nearby or a driver who obeys the law. I've sometimes been tempted to use my white cane on some of these aggressive right-turners, especially on red lights. Winter freeze and thaw cycles are hard on streets and sidewalks and on maintenance budgets. But some situations call for more than an orange cone. They need to be fixed immediately or barricaded for pedestrian safety. What kind of barricade? Something detectable by cane. This means at or below 27 inches and preferably a stride's length ahead. Here, concrete has just been poured for a new stretch of sidewalk. This thin plastic tape is too high for me to note it until I've left an unintentional autograph in somebody's fresh handiwork. And it may take more than a solid barricade to complete the job. This construction site is well protected, but how about the route around it? Or the route that will avoid it? If there doesn't seem to be too much traffic, I may use the street. It would really help if there wasn't a lane of parked cars here. Of course, Ron will have the same problem here. Too bad Hunter can't read. Well, we've almost finished filming, and not a moment too soon either. My ears are freezing. And with all I have to listen to, that could be serious. If this mid-block light had an audible signal, I'd know when I could take the shortcut across the street for a hot cup of coffee. But I think I'll go down to the intersection instead, where the sound of opposing traffic makes the crossing interval more obvious. Now you know why I'm not wearing earmuffs. You've seen how important it is to provide information that can be used by all pedestrians. Consistent design and effective communications are key for pedestrians who are blind. The access board can suggest construction details, traffic control equipment, and communications technologies that will improve pedestrian safety. When you plan sidewalk improvements, call us for help toll-free at 1-800-872-2253. Or if you're using a TTY, 1-800-993-2822. Thank you.
Here are numbers to call for technical assistance from the Access Board. The toll-free number for voice is 1-800-872-2253. The toll-free TTY number is 800-993-2822. The local number for voice is 202-272-0080. The local number for fax, 202-272-0081. And the local TTY number is 202-272-0082. Visit the Access Board website at www.access-board.gov. You can write the Access Board at the Access Board, 1331 F Street Northwest, Suite 1000, Washington, D.C., 20004-1111.